Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this lesson, we are going to look at how to determine the intervals on which a function is decreasing or increasing. That is monotonicity of a function. Thanks to Alupak from the University of Ghana, Legon, for requesting for a video on monotonicity. Now, this is the first example, but I will do two examples to increase your understanding. Find the open intervals on which the function cube root of x squared minus 9 to the power 2 is increasing or decreasing. We write f of x equal to cube root of x squared minus 9 all squared. F of x equal to x squared minus 9 all squared times 1/3, because cube root means power 1/3, which will give us x squared minus 9 to the power 2/3, that is 2/3. Now, to find the intervals on which a function increases or decreases, first you have to find the first derivative of the function. So here you take f prime of x to be equal to, and since this is a function of a function or a composite function, we are going to use the chain rule. I have a video on derivative of a function using the chain rule, so check the description for that video. So here you take 2/3 and bring it in front, times you differentiate what is inside here. For differentiate x squared minus 9, you get 2x times x squared minus 9, then subtract 1 from the power. We have 2 on 3 minus 1. So this will give us 4x on 3 times x squared minus 9 on negative 1/3. Sorry, to the power negative 1/3. So here, power negative will become positive if it becomes a denominator. So I have 4x divided by 3 times x squared minus 9 to the power positive 1/3 as our f prime of x. Now, we finished finding the first derivative. So our next step is to find the critical points. And for the critical points, we put f prime of x to equal to 0. This implies that 4x divided by 3 times x squared minus 9 to the power 1/3 is equal to 0. If we multiply 2 by the denominator, you have 4x equal to 0. Because the denominator times 0 will be 0. So this implies that x equal to 0. This is a critical point. And also, the point at which, the value of x at which f prime of x is undefined is also a critical point. And how do we find that value? Since this is a rational function, if we equate the denominator to 0, then that x value will give us the value of x at which the first derivative will be undefined. So you take the denominator 3 times x squared minus 9 to the power 1/3 to be equal to 0. We divide here by 3 and divide here by 3. We still have x squared minus 9 to the power 1/3 to be equal to 0. If we keep this and we keep this, we have x squared minus 9 to be equal to 0. X squared will be equal to positive 9. X will be equal to plus or minus the square root of positive 9. We have x equal to plus or minus 3. So our critical points are now 0, negative 3, and positive 3. Now we are going to use these 3 points to form the interval. Now, if you look at these 3 points on the number line, we have minus 3, 0, and positive 3. So you see that as we move to the left side, we moved up to negative infinity. And as we move to the far right side, we move up to positive infinity. So our intervals are now going to be negative infinity to negative 3 as one interval, then negative 3 to 0, negative 3 to 0 as another interval, then we have 0 to positive 3 as another interval, and 3 to infinity as another interval. Wow. Now, let me bring this portion. So we are going to test values on each interval to see which values will give us f prime of x less than 0 and then f prime of x greater than 0. So now, if you consider the number line, negative 3 to infinity, so we can have negative 4 here, so we can test negative 4. So here we are going to test f prime of minus 4. Here to 0 to negative 3, so we can test negative 1 there. So we test f prime of negative 1. So here to 0 to 3, so let me test 2. 2 is here, so I can test f prime of 2. And here to 3 to infinity, so I can test, okay, 2 is even big, let me test 1, or 0, 1, so let me test 1. And here to, let me test f prime of 4. Okay, so let's test the values. We have f prime of 4 to be equal to 4 times 4 divided by 4 times, it is 3. 3 times 4 squared is 16 minus 9, the power 1 out of 3. And what are we going to get? We are going to get positive. Oh, not positive. Let's check it from the calculator. If we put in 4, that is 4 times 4 divided by 3 times 16 minus 9 to the power 1 out of 3. We are going to get positive 2.79 to 3 significant figures. So it implies that here we are getting a value that is greater than 0. So we take f prime of x is greater than 0 because this one is greater than 0. Very simple as that. Now let's come to this part. If I test f prime of 1, I'm going to get 4 times 1 divided by 3 times 1 squared is 1 minus 9, the power 1 out of 3. So here I'm going to have f prime of 1 to be equal to minus 0.67 to 2 significant figures. And you see that this is less than 0. So here we have f prime of positive 1 to be less than 0. That is, any value on this interval will also be less than 0. Correct as that. Then we come here. If I take f prime of negative 1, I'll have 4 times negative 1 to be minus 4. Then 3 times 1, that is negative 1 squared is 1, minus 9 to the power 1 out of 3. That will give me positive 0.67. So here you see that if we test negative 1, we will get a value greater than 0, which means that on this interval, f prime of x is greater than 0. Then let me test f prime of negative 4. That will give me minus 4 times minus 4 times 4 is negative 16 divided by 3 times minus 4 squared is positive 16 minus 9 equal 1 out of 3, and that will give me negative 2.79, which is less than 0. This one is greater than 0, less than 0, this one is greater than 0. So here we have f prime of minus 4 to be less than 0, that is f prime of x is less than 0. So now we are good to go. So that is how we test for the intervals. Now, so we are going to draw conclusion. On this interval, since f prime of x is less than 0, we have f of x decreasing. And here, since f prime of x is greater than 0, we have f of x increasing. Less than 0, we have f of x decreasing. Greater than 0, we have f of x increasing. So we are going to state that on the interval negative infinity to negative 3 and 0 to positive 3, f of x is decreasing. And on the interval negative 3 to 0 and 3 to infinity, we have f of x increasing. So on this interval, the function is decreasing, and on this interval, the function is decreasing. And let's see the last example. The next example is, find the open intervals on which the function x cubed minus 16x is increasing or decreasing. So we take our f of x to be equal to x cubed minus 16x, f prime of x equal to 3x squared minus 16. Then we are going to find the critical points. We put f prime of x equal to 0, we have 3x squared minus 16 equal to 0. We have x squared equal to positive 16 on 3. That is 16 will come here and divide both sides by 3. We have x equal to plus or minus the square root of 16 on 3. That will give us plus or minus 4 on root 3. If you like, you can change it to decimals or you can leave it this way. Now, if you change this to decimal, you have 4 divided by root 3. That will give us 2.3 to 2 significant figures. So you have plus or minus 2.3 to 2 significant figures. So now, this is a polynomial function and it is continuous everywhere. So you will not get any undefined here because it's not a rational function. So these are the only two critical points. So now we have this on the number line. You have minus 2.3 and you have positive 2.3. So here we have infinity here, positive infinity, and here we have negative infinity. So this will give us the interval negative infinity to negative 2.3. Then we have negative 2.3 to 2.3. Then we have positive 2.3 to positive infinity. Wow. So let me do it here. Let me do it here so that it will go there. Minus infinity to minus 2.3. Then we have negative 2.3 to positive 2.3. Then have positive 2.3 to positive infinity. Or if you like, you can use what we had. So if we are going to use that one too, in case you are doing it at section A, and they've used this, here you take negative infinity to 4 divided by square root of 3, negative 1. The same thing, then here negative 4 on square root of 3, comma 4 on square root of 3. That will be the same as this interval. And this one will be 4 on square root of 3, comma infinity. That is also the same. So whether you use this or what I've done in decimal form. So always convert it to decimal form so that you can choose your values. So here, since it is negative 2.3 to infinity, I can test f of negative 3. Because negative 3 will be there. And here, since you have 2.3 going to infinity, so you see on the number line, if here is 2.3, then it means that 1 is here, and then 0 will also be there. So I'll take f prime of 0. And here, since you are moving from 2.3 going, 3 will be here. So I will take f prime of 3 to check. Okay, so let's do the easiest one first. This is my f prime of x. So if I take f prime of 0, I'll get negative 16, which is less than 0. So here, this one will be less than 0, which means that any value on that interval will be less than 0. Remember, the parenthesis bracket means that the endpoints are not included. Okay. Now, let me check this one. If I take f prime of positive 3, it will be 3 times 3 squared minus 16. That will give me positive 11. 3 squared is 9 times 3 is 27, minus 16 is positive 11. So here, this one will be greater than 0. So any value there will also be greater than 0. If I take f prime of minus 3, I get 3 times minus 3 squared minus 60, which will give me the same positive 11, because minus 3 squared will be positive 9, times 3 will be positive 27, minus 16 is 11. So this one too will be greater than 0, and that f prime of x on this interval is greater than 0. So now we are good to go. Okay. Rosina from Legon, I hope you are enjoying the lesson. Ali, I hope you are enjoying the lesson. Now, what can we see? F prime of x is greater than 0. Here we have increasing function. F prime of x, f prime of x is less than 0. So here the function is decreasing. The function is decreasing. And here f prime of x is greater than 0. So here the function is increasing. So we are going to state that on the interval negative infinity to minus 4 on 3, sorry, minus 4 on 3, and on the interval 4 on 3 to positive infinity, the function is increasing. Or if you are using the decimal, you said that on the interval negative infinity to negative 2.3, and on the interval 2.3 to positive infinity, the function is increasing. And here the function is also decreasing on the interval. If you are using this one, you have minus 4 on 3 to positive 4 on 3. And then if you are using the decimal, you say that the function is decreasing on negative 2.3 to positive 2.3. Thank you for watching, and please subscribe to my channel. I am Mensa Augustine. Bye bye.